Okay, this is going to be a quick LangSmith LLM tracing demo. I'm just going to explain how it works, what LangSmith is. This is the agenda for the demo. We're going to explain what is LangSmith. We're going to talk about the environment setup. We're going to run the demo, and then we're going to actually examine the trace and see how it works. So let's start with what is LangSmith. So this is essentially a tool or framework for developing, debugging, and deploying LLM applications in general. So you can do a lot of tracing, you can evaluate different outputs of the LLMs, you can test prompts, and you can manage deployments as well. The other important thing, this is LLM agnostic, so you can use any LLM and plug it into LangSmith and do the testing for it. This is the homepage for LangSmith. You can create a free account here, and then that'll be enough to run the demo and do the tracing. As you can see, it's a platform for agent engineering. This is meant to you can create and debug your agents with this platform. Okay, let's talk about the setup for this LLM trace. So there's going to be a bunch of steps that need to happen before we actually do the trace, and these are all the steps. So we need to install Python, ideally the latest version. We're going to create a virtual environment, install Jupyter Lab, and install the project dependencies. Then we're going to start Jupyter Lab. We also need to create an OpenAI API key. That's going to be free. However, you do need to fund the OpenAI account with at least $5 because when we make our calls to OpenAI, there needs to be a balance there. But again, each call is going to be very, very cheap, like less than a cent, but there needs to be some kind of balance there. And then the last thing is we're going to create a LangSmith API key. Here we are in our code editor. So I just want to explain what we're going to do. So this is a repo. I'll put the link in to a LangSmith course. And when I check out the repo, there's a Jupyter notebook here. So we already have Python installed. If you look here, I have 3.14 running. I already have the virtual environment set up. And all I need to do is start the Jupyter server, the Jupyter Lab server. So if I do that, it's going to start that and bring up the notebook. So before we go and look at the notebook itself, I just want to talk about some of the files here. So we're in module 0. This is the notebook that's running. There's an environment, this .env file, that has a lot of the API keys that you're going to need to run this demo. So I'm not going to click on that because those are my private keys. But here's an example where you would put it in. So you would put in your OpenAI key here, your LangSmith key here. This you would leave as true, and this would be the project. So right now it's just called LangSmith Academy, but you can name it whatever you want. You're going to see that in LangSmith when you do the trace. All the traces are going to be under that project. Okay, so here is the actual Jupyter notebook that we're going to run. So this is a simple RAG application where we retrieve some documents after the user submits their prompt, and we also call OpenAI LLM in OpenAI to generate the answer, and then we bring that answer back to the user. So I'm just going to run through this Jupyter notebook here. This explains sort of what the application is doing. And the whole idea here is we're running this call to the OpenAI LLM, and then we're going to see the trace of how that looks in LangSmith. So the setup here is you could set up environment variables using this way. You can just set them up in the notebook. I didn't do that. I used that .env file instead. So there, when it showed true here, that just means that it loaded it from the .env file. This is the actual application. It's pretty self-explanatory. It uses OpenAI. It uses the GPT-4o mini model. This is the prompt to the RAG, and it calls OpenAI to generate the response. and then it basically returns that response to our application. I'm going to run this here so you could see it going. And now we're going to actually submit the question. So we're submitting the question, what is LangSmith used for? So now it's actually running it. It's calling OpenAI, and now it generated that response right there. And that was it. So now we're going to actually go into the trace and see what happened. Okay, so here we are. We're inside our LangSmith account. And you could see here we have a couple of projects. So I'm going to go into the LangSmith Academy project. That's the one that was linked in our .env file. And if you go there, you'll see that we have all these traces. So each one of these is a trace, and they're ordered here. So the most recent one is at the top. And you could see the input here is what is LangSmith used for. So we have that input, and here you could even see the output. We can drill into that. So if we go inside, you could see all the different things that it did. So it retrieved the documents from the vector database, and then it generated the response by calling OpenAI. You could even see the number of tokens that were used. So here we could see we used 1,465 tokens. You could see how long it took, about 2.5 seconds. You could see the output right over here. LangSmith is used for developing, debugging, and deploying LLM applications, and so forth. This is what was generated in our Jupyter notebook. So just as a last part, I want to show you where the trace is on the OpenAI side. So this is the platform dashboard for OpenAI. So it's at platform.openai.com. And you could see here, if you just go to the dashboard here, and then I have a few projects here. It's under, I called it LLM testing. So if you go there and you look at the usage, you could see here, these are the calls that we made today. So there were 2 calls made today. And here it is. You could see how many tokens I used. You could see the model is GPT-4o mini, and that corresponds to what we configured our RAG application to use. So you could see as you make your calls on your application, you're going to see those calls come in on the OpenAI side.